All right, so keeping up with lessons. We're on day number 6 for the second 9 weeks. Again, today's Wednesday, March 24th. All right, so two big things we're doing. The very first thing we're going to do in the last part of section 5 here is Descartes' rule of signs. And for what we're doing on this part of it, this is honestly one of those things that, for the amount of problems we have to check, this is kind of going back to what we're doing yesterday. That yesterday, when we had, the problems that we were doing and we were doing the P over Q thing. So like yesterday, we were doing one of these problems and we had to do the P over Q and we came up with all this list of factors that we were doing here, and then we had to go back and check these. For the problems even that we're doing here, there's one thing for sure we want to show you, but a lot of this is, there was a book one time that I was teaching out of. Granted, it was a college book, but I think it was a pre-cal book. And they had like 80 numbers that they had to check with synthetic division, which was just an insane amount of numbers to have to check. And so that's one of those, if you have a huge amount of numbers, Descartes' rule of signs kind of helps out. If you don't have a huge amount of numbers, it may not be that big a help, but we're going to at least kind of show it to you anyway, so you have some idea of what it is that we're having here. So there's two things with Descartes' rule of signs that we're going to do. The maximum number. So the maximum amount of positive. So the maximum amount of possible positive solutions. Again, we're talking about solutions. They may say roots at the same time. So which way we want to say it there? Of a polynomial that they're going to call P of X. Is the number of plus or minus sign changes. Of whatever the P of X thing is that we're going to look at. Okay, so that's the max amount that you do. You basically go through and you count how many sign changes you have. That tells you the max of that. The second part that kind of throws people off a little bit. So that's the max amount, or it could be less than that. By an even number. And that's the part that throws people off, because a lot of times we'll do this and they'll get the maximum part of it. They see that and they go, okay, well, that kind of makes sense, but where's this less that by an even number? And we're going to talk about that a little bit more here in a minute. But basically, let me go back to a problem. That very last problem that we did yesterday was, here we go. And I'll put this up here in a minute. Yesterday, the very last problem that we had, we were looking for 4 solutions. What did I put here? Yes, 4 solutions, because we're way back up here. Then we had -2, 3, and then plus or minus I. That we got the plus or minus I from factoring this part off back here. This part is kind of taken out, that when we're doing these, we're talking about the actual real number solutions we can get on this thing. So we have to kind of take in consideration that you may get some imaginary answers. And because the imaginary answers come back, because we're doing x squared equals a negative number, they're always going to be the 2 signs that's here. So basically what the part we got in red here, this is saying, all right, you may have some imaginary answers that may mess up this maximum amount. So it may not actually be that. That's as big as it could be, but then it also could be less that, because you may have some imaginary numbers. And that's what that or less that by an even number thing is saying there. All right, so just to kind of give you an idea on this one. Let's say we went back and we figured out that the maximum sign changes, that the max number was equal to 5. And we'll actually do some of these here in a minute. But let's just say for a minute that we did this thing, we found out there were 5 sign changes. The possible would then be 5 or 3 or 1. Because again, you may have it, because the way the imaginary numbers work is they always kind of go together. They always partner up to pairs. And so whenever you do this one, if there's 5 sign changes, 5 is the max it could be. But again, you could have 2 imaginary answers that could knock it down. So you have 3 positive solutions or it could be another pair that's in there, so you may only have one. So this would actually be the answer if we had something like this. Same thing if we went back and counted, and let's say that the maximum sign changes we had, let's say there were 6 sign changes. Then the possible solutions that are positive, it could be the max of 6, but again, you might have 2 imaginary answers, which can knock it down to 4. You might have 2 more imaginary answers, which knock it down to 2. You possibly could have 2, so there may not be any because all the answers might possibly be imaginary. Now, that's probably not going to happen, but that's just a possibility of kind of what we're throwing at here. So just realize that everything that you do, it's always going to occur in odd amounts or it's going to occur in even amounts. And that's really what it comes down to. Okay. And then we'll say the max amount of possible negative solutions. Is the number of plus or minus sign changes of P of negative X. Okay, so for positive numbers, we use a positive X. For negative solutions, we're using a negative X. And again, we can say or less that an even number. So same thing is true on this one that was on the first one, that you can always kind of take this thing back in amount in even amounts so that you can always knock it down from that one. All right, so here's some, we're going to do a couple examples so you can kind of see what's going on. So they should tell you to use Descartes' rule of signs. And then they should give you 2 parts. So part A is find the possible positive zeros. And then the B part is to find the amount of possible positive negative roots. Okay, now, and this is one of those things where it's really easy to do, but at the same time, it's also really easy to mess up. And just to kind of show you this one, I found this one time and I thought it was kind of neat. So I always like to bring this in because it sounds really easy to get the sign changes that's here. But let me show you this one in a little brain teaser that we've got here. Okay, just to show, and this is kind of the same thing here. Count the number of F's that appear in this sentence. Okay, so take like 10 seconds, and I know it's language, but still, same thing here. So see how many F's you've got in that sentence that you can find. All right, so what do you think? How many F's are there? All right, somebody said 5, somebody said 6. Anybody else got a different number? Earlier class, some people said 3, some people said 4, somebody said 7. If you go back and count, For the people that said 3 or 4, well, here's 1, obviously. There's 2. But a lot of times we tend to skip over this second F. I don't know why, but we do. So there was 1, there's 2, there's 3, there's 4. There's another one right there. There's 5. And there's 6. Okay, so if you said 6, you got it. If you said 5, you missed 1. Some people said somebody said 3. Some people said 4. So it's one of those things that seems really easy, but at the same time, we can come up with a bunch of different answers on this thing. I was going back and reading this one. Somebody got kind of smart at it. They were like, well, there's only one F. All the rest of them are lower Fs. And it was like, okay, somebody's getting smart on that one. But yeah, anyway. I wish I could find the one. There's another one where they take a paragraph and they jumble up all the words inside each word. They rearrange it, but you can still read it. Because the way your brain is geared, it'll actually figure out what the word is without actually being in the correct order of it. So see if I can find that one sometime. Okay, so for this one, we're going to do the same thing. Let me give you a problem here, and then we'll run through it. So for example 1, let's say that our P of X is 9x to the third minus 4x squared plus 10. Okay, so for part A, it's going to be really easy. We're just going to count how many sign changes we have. But it's one of those things that if you don't slow down and take your time, it's easy to miss this problem. Okay, so best thing to do is just take everything off, no numbers, no variables, just give me the signs. This 9 is positive, this 4 is negative, and that 10 is positive. All right, and here's where you go back to like second grade math, and where you go from here to here, you bounce from here to here. Well, that changed it from positive to negative, so that's one sign change. If we start here and go to here, we changed again, so now there are 2 sign changes. So the max would be 2, but again, it could be that both of those answers might be imaginary. So if they're both imaginary, we have to kick both of them out. So it could be that there's maybe 2 or 0. Okay, so when it says the possible positive roots, well, there possibly could be 2. That's the max it could be. But again, it could be that both answers are imaginary. And if they're imaginary, we kick those out. So there could be none. It's actually positive real number of roots that we could have for this thing. Okay, so that's what we're doing when we're counting the signs on this thing and kind of figuring out what's happening with it here. All right, now to get the B part, this is a part that takes a little bit of work to it. Is instead of doing P of X, we're going to do P of negative X. So we're going to take that same equation we got, and everywhere you have an X, you have to take it out and put in a negative X because we're figuring out the negative solutions. So basically, it would be something like that. All right, and those you have to actually kind of simplify it because basically we've got a positive 9 here, and we're going to multiply that one. And go ahead and do negative X to the third. If you do a negative times a negative times a negative, that's going to be a negative. So that's a positive times a negative, so that's going to make that a negative. This one is negative 4 times, and if you do a negative times a negative here, that's going to make that a positive. So that's a positive times negative, so that one's also going to be a negative. And then the 10 at the end never changes because it's just a constant, so that's going to make it a plus. Okay, so when you're doing these, again, you don't necessarily have to worry about what the X or the thing is. You just need to worry about is it positive or negative. If I do negative X to the third power, that's going to be a negative. So now I'm doing a negative times positive, so that one's a negative. And then same thing, count your sign changes. We start here and go to here. That didn't change. We start here and go to here. That one did change, so there's one sign change. So there's one that could be negative. So up here, this was the positive solutions. So there could possibly be 2 answers that are positive or none. This one says there's only one negative solution, which means that if we were going back to what we were doing yesterday and we were doing this problem, if this had been kind of the way we did this one, as soon as this answer came out to be negative and it checked out, we would have not have gotten another positive answer if that would have been for the use of Descartes' rule of signs. So that's kind of what it's telling you, is that once you get one negative answer, you don't have to check any other negatives because they cannot be the correct answer because there's only one negative solution that you can use. Okay. Now, again, you're probably not going to do that on these because most of the problems are going to be fairly short. So you're not really going to have to check these and go back and do this. Now, here's the big one that you kind of want to use that jumps out at you. And this is the one I tell people, this is the one that you want to kind of have in your back pocket because this will save you some work when you go back and start checking these things. So we're going to do P of X is equal to 8x to the third plus 2x squared plus 16x plus 8. All right, and part A is really easy because, again, you don't have to change anything, just pull the signs out. That's positive, 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 positive. How many sign changes? None, right? When it stay positive all across. So if there's no sign changes, that means that there are 0 positive solutions. Okay, and that's the one I want you to kind of see, because if you run across a problem and you look at it and it's all positive all the way across, or it's all negative all the way across, and you got to go back and go through that list and check all these numbers, you don't have to check any positive solutions because there's no way you can plug in a positive number here and this thing can ever be 0. We had one yesterday that was really close to that. I think it's that one we just put up there. The one example 3 we did yesterday, if this very first number here had been negative, we'd had negative all the way across. When we came up with this list of numbers that was here, we wouldn't have to worry about checking any of the positives because if there's no sign changes, then there's no way those positive solutions could work. We'd have to pick a negative number. So we could only pick -1, -2, -3, or -6. And that's kind of what I want you to see. So if you do that at the beginning, and that's kind of that just want you to kind of look at it. If you look at it real quick and just notice that all the signs are the same, that means you don't have to check any positive numbers. You're only going to check the negative numbers, which, okay. And then we'll get to the B part, and that'll tell us how many possible negative solutions we could have. All right, so if we do P of -x, so that's 8 times -x to the third plus 2 times -x squared plus 16 times -x plus 8. All right, that's a positive 8. And if you do negative times negative times negative, that's going to make that a negative. So positive times negative makes that a negative. All right, we've got a positive 2. If you do a negative times negative, that makes that a positive. So a positive times positive makes that one a positive. This one is just a positive times a negative, so that one's a negative. That one's a positive. So if we look at all of our signs, there's what we've got. Okay, now, and again, don't get in too big a hurry because a lot of times people will see this and they'll have it and then they just count wrong. This is one you got to kind of slow down and take your time and go back to like 2nd grade. Go from this one to this one. It went from negative to positive, so that's 1. If we start here and go here, that's positive to negative, that's 2. If we go here and here, that's another one, so that's 3. So the max number is 3, but again, a couple of those answers could be imaginary. So we'll say that it could be 3 or it could be 1 negative solutions. Okay, so that's kind of, if you're going to actually use it in a problem, that's the one you want to look for. That if all the signs are the same, just realize that you don't have to check any positive numbers. You need to only check the negatives to kind of see what you're doing. Okay, so you'll have a couple of those in the homework to kind of go through just to practice with a little bit. But that's kind of just what you're thinking. Again, don't get in too big a hurry, because sometimes if you get in too big a hurry, you can take something that's really easy just by counting the signs, and you can kind of skip through it and mess this thing up just by trying to rush through it. So just remember to kind of take your time when you go through that. Okay, and then the last big thing we got to do today, and this is where we'll kind of tie these two things together. And we've already kind of talked about it here for this one. And we're going to say this. Complex numbers and radical roots for everything that we're doing solving wise, those are always going to occur in conjugate pairs. All right, and if you remember, I think this was Friday because we were out Wednesday and Thursday last week. I think we talked about it on Friday. Maybe might have been Tuesday. But if you remember conjugate, we said conjugate just means you just change the plus or minus sign. So in this case, you change the plus or minus sign in front of either the complex number or you change the plus or minus sign in front of the radical. So it's got to be either complex or it's got to be radical when we go through those. All right, so what we're going to do is just to kind of give you an idea of this one. Let me give you some of these to kind of make sure we've got it, and then we'll show you how this thing would kind of go about this one. So let me say I'm going to give you a solution here. And then we're going to tell me what the conjugate solution is. Okay, so we're doing 2 minus 3i. So if you're given 2 minus 3i as one solution, the conjugate solution then would be 2 plus 3i. All right, so your answer was square root of 7. I said, all right, tell me what the conjugate solution would then be. Just say, all right, if that's a positive square root of 7, then the conjugate would be the negative square root of 7. So if they give us one answer is 4i. The negative 4i would be another one. And if you have 1 minus the square root of 2, change that to 1 plus square root of 2. Okay. But the main thing is on this one is that it's only the complex numbers or the radical numbers that's going to do that. If it's a real number, like when you have 1 that's here, you don't change that one. Real number here was 2. We didn't change that one. You only change either the complex part or the radical part. You don't change the real number part because it stays like it is. All right, so here's what you're going to have. You're going to have a couple of problems where it's going to ask you to do something like this. Let's say something like this. A polynomial has roots of square root of 3 and 4 plus I. And they're going to say, all right, just name the other roots. Oh, sorry, you can't see that, can you? There we go. How about that? Okay, so it says name the other roots. So you've got a positive square root of 3. So just change it to a negative square root of 3. It gives you 4 plus I. Just change it to 4 minus I. Okay, that's all you have to do. So if it just says name it, that's all you have to do. You don't have to do anything else with it. Just tell me what it is, and then that's it. All right, and I always like to throw this one at you because sometimes this is the one that throws people for a loop. Cubic polynomial has roots of 5/2 and 3 minus 2i. And the other root. All right, and sometimes the words kind of give you a little hint. This one said name the other roots. This one just says name the root, right? So you got the 3 minus 2i, so I'll be able to put 3 plus 2i. But for that one, that's it. Because remember, if it's a whole number or if it's a real number like 5/2, you don't do anything with that one because that's it. The other hint they kind of gave to you on this one, they said it was a cubic polynomial, which means that's x to the third, which means you need 3 answers. So if that's 1, that's 2. As soon as you change that one, that's 3. So then that would be all that you'd have to do. So again, if it's a whole number, even if it's a fraction, as long as it's a real number answer, you don't have to worry about changing that sign. You only change the part that's imaginary, or you change the part that's got a square root with it. If it's just a actual real number, then that's it. Then you don't have to worry about changing anything on that one. All right, and then the last thing we're going to do. And again, we did this one. Again, I think this was Friday. We did this last week. We're going to write an equation given the solutions of x equals -2 and x equals 3/5. Okay, for the people that weren't here, because I know we had quite a few people that were out for one reason or another last week. Basically, here's what we're doing. If they get, this is the Jeopardy question. They've given us the answers. We got to go back and figure out what the question was. So for these, the very first thing we're going to do is we're going to take the solutions we have, and we're going to, whatever the number is, we're going to do the opposite of that. We're going to move it back over to the other side so that you get something equal to 0. And that's kind of the big catch on these, is that it's got to equal 0. This one was a positive 3/5, so to move it back over, we'd have to subtract 3/5. So that's going to be x minus 3/5 equals 0. And what we said is that if you get one of these that's got a fraction, because we don't like working with fractions, this is where we can actually do bottoms up like we did way back when, that we can take this thing as x plus 2, and we're going to rewrite this one as 5x minus 3. So that way we get rid of the fractions. We don't have to worry about it. All right, once we're there, now we're going to go back and just do the full method. So we're going to do x times x, or x times 5x, and x times 3. And then we're going to do 2 times 5x, and 2 times -3. All right, and just about every single time when we do this one, you can always put these middle terms together. So we have 5x squared. We're going to make that 7x and then minus 6. That's for equation, then we just set that equal to 0. Okay, so that's what we were doing. I think it was Friday last week. I think that was in section 3. We kind of went over that one. We're going to do the same thing today, but they're going to add in either a radical answer or a complex answer. So we're going to kind of look at what you're going to do if you have a complex answer. But it's basically the same thing. It's just got one extra little step that we have to do with it. So last one you've got to write down. There's going to be one more that we're due, but I'm not going to make you write it down. Just want you to kind of watch this one. So this one will say, write the polynomial equation with roots of -4 and 2i. Okay, now again, they've got the roots on this part of it. So for those, that's our solutions. Because again, roots, answers, solutions, it all means the same thing. That's x equals -4. That one's x equals 2i. The one thing you've got to know, and this is kind of what we're doing with the parts here, if they give you this solution that's an imaginary solution, you also have another imaginary solution that's going to be -2i. So if they give you positive 2i as a solution, you've also got -2i as a solution. So you always have to bring in that conjugate answer for whatever they give to you. They give you one, you got to tell me what the other one is. All right, and from there, though, everything else we're going to do it the same way. We're going to add this 4 over to here so we can get this equal to 0. We're going to subtract this 2i so we can get this one equal to 0. And then we're going to add 2i to this one so we can get that equal to 0. Okay, and then once you've got them all set equal to 0, then you bring them all back together in parentheses. And then we're going to multiply all that together. All right, now, when you get these, here's the one hint that you want to have for this part of it. When you're here, you want to multiply the complex numbers or the radical answers first. And if it was square roots, you would kind of want to do that same thing, because if we do that, this thing is going to clean up a little bit nicer. So we're actually going to do the full method on this part of it first. That's what we're going to do here. So we'll do x times x and x times 2i, and then 2i x times 2i and 2i. All right, so x times x is x squared. We've got x times 2i, that's going to be 2ix. You've got -2i times x, that's going to be the same thing, but it's minus 2ix. And I always like to do this one because sometimes people forget. We're going to do -2 times 2, which is -4. And remember, if you do I times I, that is I squared. Okay, so that's everything back here. The x plus 4 that we had in the beginning, it's still kind of hanging out. So we're just going to kind of, put an arrow, because eventually we're going to come back and get that one. But right now we're worried about these two. The great thing about this one is that when you multiply the conjugate numbers together, we said the O and the I will always knock each other out, because if you do +2 minus 2, well, that goes to 0, so that's out. And that's why we do that first, because now it makes this thing a lot easier, because now, hopefully remember, if we have I squared, you're going to replace that with -1. So it's -4 times -1. This thing is going to be x squared plus 4. And then if we bring down that x plus 4, we've got that one. And then we get to do the full method one more time. All right, so now we've got x times x squared, which is x to the third. We've got x times 4, which is 4x. Then we're going to do 4 times x squared, which would be 4x squared. And then we're going to do 4 times 4, which would be 16. And most of the time on this one, they want you to rearrange it so it's in descending order. So final answer would be x to the third plus 4x squared plus 4x plus 16. And they'll either put that you have p of x equals this thing, or they'll put that this thing equals 0. They can kind of go either way on this part of it. So they may give you this answer, or they may give you this answer. The main thing is that you've got this part right here, because they'll either give you this answer blank and they'll give it here, or they'll have it equal 0, and then you're still going to have an answer blank there. Okay, now last thing I'm going to show you. Y'all don't have to write this one down. I just want you to see this one so you kind of see what it is it looks like. So as far as writing down notes, that's it for today. We're done. But let me just show you this one, kind of pull it back a piece at a time here so you can kind of see what it looks like. Because it's almost the exact same thing. It's just a different, it's a little bit longer step. So as long as you've got it, we're okay. This one says find the polynomial equation with the roots of -3i, 8, and 2. Again, you don't have to write this one down. You just kind of watch. Main thing is, you know that you've got to have, they give you -3i. You've got to know that +3i is also a solution. We also got x equals 8, x equals 2. You're still going to say add or subtract these numbers over so that you can get them all equal to 0. And then once you've got them all equal to 0, we're going to go back and multiply them together. And just like we did on the last problem, we're going to do this one first. So we're going to kind of just cover that up for a minute. We're going to do the full method here. And again, the whole reason that we do that is that if you multiply these numbers together, the O and the I will knock each other out. So you're left with x squared and then minus 9i squared. Change that -1, plug it in for I squared. So that's really x squared plus 9. All right, and then over here, we're going to do the full method on this side. So now we're doing x minus 8, x minus 2. We do the full method here. We get x squared minus 10x plus 16. So now we've got these two things multiplied together. All right, main reason I want to show you this one was that now you could go back and do x squared times this, and x squared times this, and x squared times this, and then do 9 times this, and 9 times this, and 9 times that. You can do that, but if y'all remember way back when we said there was a little bit of a shortcut you could do, where instead of doing all that, you could actually just go back and stack these two things on top of each other. And then do it like the old division we did way back when. You can do 9 times 16 and get 144. You can do 9 times -10 and make that -90x. And you can do 9 times x squared and make that 9x squared. Okay, and then you can go back and multiply everything by x squared. So now you're going to do x squared times 16. And that 16x squared, instead of stacking up here at the end, just stack it underneath the term that's already got the x squared with it. So that would go there. You're going to do x squared times -10. Well, that's -10x to the third. Well, x to the third should go right in front of x squared. And then we'll do x squared times x squared, which will be x to the fourth. And the main reason I'm doing that is that now, instead of all these terms being spread out, if we multiply these things out, they'd be all over the place, kind of spread out. Now everything's kind of stacked up. So you get x to the fourth minus 10x to the third plus 25x squared minus 90x, and then plus 144. Okay, so the main reason on that one, again, is just to kind of clean things up a little bit. So instead of having these numbers all over the place, because sometimes when y'all move some sign, I'm the same way. When I move these around, sometimes I'll miss a negative when I move these, or I'll do something weird. If I stack this up, it seems like it's a little bit less, combining like terms is a lot easier because now you're just adding up and down and you're not having to move anything when it goes across there. Now, if you still want to go back and, multiply this times this and this times this and have all the arrows over the place, you can. This is just an option you can do that makes it a little bit cleaner. So. Okay, so that's all we've got for today. And that'll wrap up 5.5. We could try 5.6, but we'll just wait and kind of hang on to that one, get that the next day.